Hey guys, this lesson is about multiplying and dividing rational expressions. So our learning target is I can multiply and divide rational expressions. The first thing I want to talk about is this word rational. So this is our rational unit, and I know it's kind of scary, but anytime we see the word rational, what that really is referring to is fractions. So this unit is a little scary at first because we are dealing with fractions. We're also incorporating quadratic expressions, linear expressions, all that good stuff, and factoring. So sometimes it can be a little daunting at first, but we'll take it slow. You can pause the video. You can email me questions. Whatever we gotta do, we will figure this out together. So, all right, here we go. Okay, so here's our first example. We're going to simplify the fraction 32 divided by 24. So, before you go ahead and get your calculators out, I know you know how to do this in your calculator and hit math and enter, and it'll give you a fraction. But what I really want you to understand is what you're doing when you simplify a fraction. So this is what we're going to do. We're going to do those little factor trees that you did back in middle school. So I need two numbers that multiply to give me 32. I'm going to go with just the obvious 16 and 2. I'm going to circle 2 because that's a prime number. And then I'm just going to break the 16 down further. So two numbers that multiply to give me 16 are 2 and 8. Once again, I'm going to circle the 2 because it's prime. I can't break that down any further. 8 I can break down into 2 and 4. Circle the 2. 4 I can break down into 2 and 2. Alright, so there are 5 2s. So I'm going to rewrite 32 as 2 times 2 times 2 times 2 times 2. And then I'm going to do the same thing with 24. I want two numbers that multiply to give me 24. 2 and 12. Circle 2 because it's prime. Two numbers that multiply to give me 12 are 2 and 6. Circle 2 because it's prime. And two numbers that multiply to give me 6 are 2 and 3. So now I'm going to rewrite 24 as 2 times 2 times 2 times 3. So what I'm essentially doing is I'm factoring it completely. I'm breaking down the factors. And then any factor that it has in common on top and bottom, I'm going to cancel those out. So there's a 2 on top, there's a 2 on top. Here's another 2 on top and a bottom top, another 2 on the bottom. And then another 2 on top, a 2 on the bottom. And so now what I'm looking for is anything that's left. So on top, I have a 2 times 2, which is 4. And then on the bottom, I have a 3 that's left. So this is the simplified version of 32 over 24. It's 4 over 3. So that's what you're doing when you simplify a fraction. You are breaking it down into factors, and you're canceling out any common factors it has, and then you're writing what's left. So we're going to use that when we do simplifying rational expressions. Okay, so here's our first one. We got 20x to the 6th power divided by 14x squared. We are going to do exactly like we did in that first problem. We're going to factor this as far as we can get it, and then we're going to cross out anything it has in common on top and bottom, and then we're going to write what's left. So some people don't need to do this, but some people do. I'm going to do the little factor trees for 20. So 2 and 10. 10 is 2 and 5. I'm going to do the factor tree for 14. The easy one, just 2 and 7. And so what I'm going to do is I'm going to rewrite that top as 2 times 2 times 5. That's just like that first example we did. And then remember, x to the 6th power is the same thing as writing 6 x's. Alright, so there's our top. It's factored completely. I'm going to rewrite the bottom. 2 times 7, and then we have x squared on the bottom, so that's 2 x's. Okay, so I did these in 2 different colors so you can distinguish between the top and the bottom. So we have factored it completely just like we did in that first example. And now we're going to cross out any common factors it has. So there's a 2. There's no more numerical factors that it has, but look at the x's. You have an x on top and an x on the bottom, another x on top, another x on the bottom. I'm going to circle what's left. So we have a 2 and a 5 on top. And then we have these 4 x's, and on the bottom we just have a 7. And so we're just going to multiply anything back together. 2 times 5 is 10, of course. If you have x times x times x times x, remember that's 4 x's, so we just write x to the 4th. And on the bottom you have a 7. So very similar to that first one we did. I'll go back to that one. We factored it completely. We crossed out the common factors. Anything that was left on top, we multiply back together. Anything that was left on bottom, we multiply back together. And then we did the same thing with this one. We just have numbers and letters. And then now we're just going to make it a little more complicated, because that's what math does, always. But it's pretty much the same process each time. Okay, this one is a little more difficult, just because on top we have a binomial, and on the bottom we have a quadratic, so you have to remember how to factor quadratic, so that's why we spent lots of time on it before. The bottom is the only one that's a little trickier, so I'm just going to go ahead and rewrite the top, because there's not a GCF we can take out, there's actually nothing else we can do. But for the bottom, remember, this is when you can use the shortcut method because there's an understood 1 in front of the y squared. So I'm just looking for 2 numbers that multiply to give me negative 48, the last number. And then 2 numbers that also add to give me 2. And it takes people a little bit of time, but the 2 numbers are 8 and negative 6. And so my 2 factors are going to be y plus 8 and y minus 6. So that is how you factor the bottom. So I'm going to rewrite that over here so you can see it completely factored. So once again, it's just like those first 2 problems where we factor it completely. You can see it a little better now, and now we're going to look for any common factors it has on top and bottom. So we don't have any monomials that we can take out, but look for a binomial that they both have. If you'll notice, they both have this y plus 8, and that all goes together because that is a binomial. And then just remember that there is not a 0 on top. It's kind of like dividing y plus 8 by y plus 8. And if you'll think about that, that's actually a 1 on top, and then a y minus 6 on the bottom. So that is my simplified answer. And if that didn't make any sense to you, why it looks like that, if you'll think about, what if you had like a problem 3 over 6? So if I factor that out, it looks like this. So notice it has that common 3 on top, but that doesn't become 0 over 2. It becomes 1 over 2 because 3 divided by 3 is 1. So it's the same reasoning that we used back in elementary school and middle school, but maybe you've forgotten, and I'm trying to get all of that back in our brain. Here's my danger. This one, they love to put things like this on the ERC. Sometimes I'm seeing it on the ACT. It's the bottom part that is the danger part. So if you think about back when you're learning quadratics or even linear, when you talk about standard form, you always want the variable with the biggest exponent first. So if you look at this bottom, if you'll notice, it's actually rearranged than what we usually see. Usually the x would come before the number. So here's what I'm going to do. I'm going to flip this around. So notice that is a negative x, and that is a positive 7. So this is what it really should look like, but it's really ugly. We never want our leading variable to start off with a negative. So what I'm going to do is I'm going to take out a negative 1 GCF. And remember that anytime you take out a GCF, you're really dividing each of those terms by -1. So, negative x divided by -1 is a positive x. Positive 7 divided by -1 is a -7. So we did all of that just to show you that that bottom can be rewritten as -1 parentheses x-. So that's going to be our new bottom. This is how you would properly write it. And then if you look at the top, you got x squared minus 49. That's a quadratic. It can be factored. You're looking for two numbers that multiply to give you -49. Notice there's no middle term, so you need two numbers to add to give you 0. This is a difference of squares problem. The answers are -7 and 7. So on top, my factored form is going to be x minus 7 and x plus 7. Okay, so we have completely factored the top, we have completely factored the bottom. We're looking for monomials or binomials that they have in common that you can cancel out. So the thing that they have in common is an x minus 7. I'm going to go ahead and cancel that out. And then I'm left with x plus 7 on top and -1 on the bottom. So you're probably not going to see this answer, because that's really not how we would write it. What you could see is, if you think about it, like dividing each of those terms by a -1. So x divided by -1 would be -x, and then 7 divided by -1 would be -7. I think you would be more likely to see that one that is the square around. Not that the one that's circled is necessarily wrong, it's just not like grammatically correct, if you can think about it like that, like math grammar. Yeah, just something to think about. Anytime you see something like the very beginning right here, anytime it is flipped around, it's not in standard form, you're probably going to be taking out a -1 GCF, rewriting it, just some weird stuff to think about. Okay, so I want you to try this one. I want you to notice that the top is that flipped around standard form, so you will be taking out a -1 GCF. The bottom is a quadratic, and it is not the shortcut quadratic, so because there is a 3 in front of x squared, you will have to factor by grouping. So if you need to look at previous videos on what to do, you can do that, but I'm going to let you hit the pause button and try this problem in 1, 2, 3. Okay, so hopefully you took that time to actually try the problem. And now let's go over it. So the top is, once again, it's that flipped around standard form. That's not how we ever see it. So what I'm going to do is I'm going to take out a -5 GCF. And when I do that, I get x minus 9. So that's going to be my top. Okay, and then the bottom is when you have to multiply the a and c terms. So here's my A, here's my C. I need two numbers that multiply to give me 3 times 9, which is 27. But they have to add to give me that -28, that middle number. So sometimes that's hard for people, but it's -1 and -27. I use those two numbers to rewrite the middle and put an x beside of them. I group them, and I pull out GCFs. And remember, for the second set of parentheses, since that is a -27x, you have to take out a negative GCF. Remember that you want... Oh, what the heck am I doing? Hold up. Oh. You see what I just did? I did not take out the greatest common factor. Let's go with a 9. There we go. Alright, so this is how I knew I was wrong, because those parentheses were not going to match up, which is the whole point of this. So, if your parentheses don't match up like mine were about to, then you need to change what you're doing and fix the problem. Okay, so I'm going to rewrite this whole problem. So the top became this. So I'm going to put that down here. -5x minus 9. And then I'll do this one, let's do green. The bottom became these two parentheses, 3x minus 1 and x minus 9. So you had to know how to factor in order to do that. If you're having trouble with factoring, make sure you watch some more videos, email me, get some more practice in, do what you need to do. Okay, so now that we have completely factored the top and the bottom, we're looking for things that we can cross out. So it has a binomial of x minus 9, and I don't see anything else to cross out. So we are left with a negative 5 on top and a 3x minus 1 on bottom. And that is our final answer. Woohoo! Okay, so let's jump to multiplying rational fractions. I pulled up this problem, so maybe you remember doing fractions, maybe you don't. Either way, we're going to talk about it. So in order to multiply fractions, these are pretty easy. You don't need to have like common denominators or anything. All you have to do is multiply the top and bottom together, which is what you were taught in school. But what I'm actually going to get you to do is, once again, factor it completely. So we don't need to make a factor tree for 2. It's just 2. We don't need to make a factor tree for 3. It's just 3. If you need to make a factor tree for 6, you can. The only two numbers that multiply to give you 6 are 2 and 3. And the only two numbers that multiply to give you 10 are 2 and 5. So what I do for these is I just make them one big fraction, because that's all you do when you multiply fractions. You just multiply across, you multiply the numerators together and the bottoms together. But before we do that, just go ahead and look for anything it has in common. So you'll notice they have a 2 on top and bottom, and they have a 3 on top and bottom. So let's go ahead and get rid of that. And look, pretty easy. What's left on top? 2. What's left on bottom? 5. And we're good. So probably in school what you were taught to do is multiply like 2 times 6 is 12. And on bottom, 3 times 10 is 30. And then you will reduce that. Perfectly fine. You're going to get the same thing. I just wanted you to look at if you factor first and cross out stuff, it can kind of be like a shortcut way, and that's actually what we're going to do on the next problem. Okay, so I put some steps on here. Oh, and if you'll notice, I even have... Okay, I fixed my little spelling error. There we go. So how to multiply rationals. First, we're going to factor completely, of course, that's what we keep doing. And then second, we're going to cross out common factors on top and bottom. So I'm going to use 4 different colors, maybe 4, just so you can see this. So the top is going to become, if I break down a 6, that's a 2 and a 3. X squared means 2 x's. Y cubed means 3 y's. So there's our top. And then if I do the denominator on the first one, I have a 2, x times x, y times y. Same thing for this one. The second numerator, if I break down the 10, that's a 2 and a 5. X cubed is 3 x's. Y to the 4th is 4 y. And then I'll do the same thing for that bottom. If you break down 18, it's going to be a 2, a 3, and a 3. And y squared is going to be y and y. So now I have completely factored everything. And remember, because I'm multiplying, this just really becomes one big giant fraction. And so it all goes together. And I'm just going to start crossing out anything it has in common on top and bottom. So here's a 2. And here's another 2. Let's see, a 3 that I can take away. 2 x's, 2 y's. Another set of 2 y's. And I think that's it. So I'm just going to use purple. So here's a y. 5. 3 x's and 2 y's. And on the bottom, I'm just seeing a y. And then I'm just going to write what's left. So on the top, I have a 5. I have 3 x's, so x cubed. I have 3 y's all together, so y cubed. And on the bottom, I just have a 3. So that's my final answer. Pretty easy. Just if you're kind of a messy writer, cough, Caleb Paul, cough, you might want to just be as neat as possible. And you can color code if that helps you. If not, okay, so let's do a little bit harder example. We're going to factor completely, then we're going to cross out common factors on top and bottom. So I'm going to do the same thing. I'm going to do 4 different colors so you can see the different ways we're going to do these. So I'm going to do that first numerator. That one I'm going to factor out by taking a GCF out. If you'll notice that both of those you can take out a 4x. And then when you do that, you're left with x minus 1. Alright, and then for the first denominator, I'm going to do in red, I can automatically see that I'm going to take out a 2 GCF, so I'm going to write out what's left. And then here's that shortcut method. I need 2 numbers that multiply to give me -3, but they have to add to give me 2. So those numbers are +3 and a -1. So my bottom is a 2, an x plus 3, and an x minus 1. Alright. Now I'm looking at that second numerator. I need 2 numbers that multiply to give me -6, but they have to add to give me 1. Those 2 numbers are 3 and -2. So this factors into x plus 3, x minus 2. And now I'm going to do that second denominator. It has a GCF of 4x, and when I take out a 4x, I'm left with x plus 3. Alright, I'm going to try and clean this up a little bit. So this denominator was a 2, x plus 3, x minus 1. Okay, so I've factored completely, and now I'm just going to start crossing out any common factors I have on top and bottom. Remember, this is one big old fraction. So I see that there's a 4 I can take out. There's also an x. There's an x minus 1. I see x plus 3. I think that's it. So let me change it to purple. So here's what's left on top. I got an x minus 2. And on bottom, I have a 2. And then an x plus 2. So this answer is perfectly fine. Just so you know, I have seen it where sometimes they will distribute that denominator back together. So if you also saw this as an answer choice, just remember that both of those are the same thing. Smiley face. Okay, so I'm going to let you try this one. I'm just going to caution you on that very first numerator. That is one of those danger. Make sure that you put it in standard form. See if you can take out a GCF. Hint, hint, hint. So you try. And pause the video in 1, 2, 3. Okay, so I'm going to go over what I get for when I do this. So that first numerator is, if you'll notice, it's not in standard form. So I'm going to write it in standard form. Also, we never want a negative to start off a variable, so I'm going to take out a -1 GCF. And then that will change all of my signs. And now I'm going to factor this. I need 2 numbers that multiply to give me -8, but add to give me 7. Those 2 numbers are +8 and -1. Okay. So then, it's pretty nice. So the denominator on the first one, I don't have to do anything to. Also, same thing, the numerator on the second one, I don't have to do anything to. And then the denominator on the second one is just taking out a 9 GCF, and you're left with x minus 1. Alright, so I'm going to get rid of this just so it's a little bit easier to look at. Okay, so it is completely factored now, and I'm just trying to cancel out anything I see on top and bottom. So I see an x plus 8, also see an x minus 1. I got a -1, that's important. I have an x plus 5 on top, and I have a 9 on the bottom. So negative 1 x plus 5 over 9. That's a little ugly the way it's written. So some different things you could see. You could see just a negative up front and an x plus 5 over 9. You could also see, like, if they distributed that negative, you could see it like that, but I don't like that. This is the one that I would put as a quiz on a test if I make it. But just know that all three of those are equivalent to each other. So let's look at dividing two fractions, and there are numerous ways that you could have been taught back in middle school. I think the most common is same change flip, so it's actually multiplying by the reciprocal, but I just used this little phrase because so many people have used it in the past. So same means you keep that first fraction the same. We're going to change the problem to multiplication, and we're going to flip that second fraction. So I'm going to rewrite the problem. So the first fraction stays exactly the same. We're going to change this to multiplication, and we're going to flip the second fraction. So remember, that is because you're multiplying by the reciprocal, but then just the easier way is just flip to help you remember. Okay, I'm going to run out of room, so let me see if I can erase this. Oh. Alright, give me just a minute. Oh, wow, it's like magic. Okay, here we go. So I've just rewritten the problem. I'm going to pause the video really quick, and I want you to pause it and see if you can factor this completely before we go on. Okay, so this is what I get when I factor completely, just to save a little time. And now what I'm going to do is just look for things it has in common. So remember, the whole point of doing same change flip was just to make it a multiplication problem, and then it's exactly like the ones we have been doing. So we got x minus 6 to take care of. I see an x minus 3. I see an x squared. So notice I forgot to break down the 8. So you can think of an 8 as being like a negative 1, a 2, a 2, and a 2. And so there's actually a 2 that you would take out. Alright, so the only thing I see left on top is x minus 5. And then got several things going on bottom. You got this x plus 2. And then you have a negative 1 times 2 times 2. I'm just going to multiply all that together. So negative 4 x plus 2. So remember, that's probably not how you're going to see it. You could see it like this. You could also, I don't know, you could see it a bunch of different ways. Just remember what equivalent forms look like. They're all the same. Alright, I want you to try this one. It's a little wonky, sorry. So that is 1 divided by 5x squared. Divided by 9x minus 36 over 5x cubed minus 35x squared. So pause the video in 1, 2, 3. Okay, so the first thing you're going to want to do is do same change flip. So I kept the first fraction the same. I've changed it to a multiplication table, and then I have flipped the second fraction. Now I've factored everything completely, and I've crossed out what it has in common on top of the Alright, hope you found this helpful. If not, you can email me anytime you feel like it.